Greetings, fellow mathematicians. We're going to take a look at another straightforward quotient rule question. The difficulties here lie with the interpretation of A, B, C, and D as constants. Now let's take a look at the basic example, the derivative of 2x. There we think of the constant 2 as a constant multiple. So when we differentiate 2x, we use the fact that x differentiates to 1, 2 is a constant multiple, 2 just multiplies that derivative. You're probably very comfortable with that, just immediately saying the derivative of 2x is 2. Now for this problem, we have the similar calculation. We'll be differentiating ax, where a is a constant, and that derivative comes out to a, the constant multiple. Once you're comfortable with that, the rest of the calculations will be very simple. So let's go ahead and approach this by applying divide and conquer. We're going to identify the numerator as f and the denominator as g. So let's write that down. F of x, we'll write that as ax plus b. And g of x, that'll be the denominator cx plus d. And there's really two types of terms that we'll be differentiating, those with x in them, and then b and d, those terms without x. B and d are constants. They're going to differentiate to 0. But ax and cx, they're going to differentiate to a and c respectively. So if we write down f prime, the derivative of ax is a, and differentiating b, which is a constant, there's no x multiplying it, a constant differentiates to 0. So f prime of x is just a, and similarly g prime is just c. And the last step is really to take all these pieces and just combine them back together with the formula for the quotient rule. All right, so our function was h of x. We're going to be calculating h prime of x with the quotient rule. We already did all the work. We just have to put the pieces back together. So we start with f prime times g. So we get a times cx plus d. We have a minus, and the next term is ax plus b, f, times g prime, which is c. All right, and that's all over g squared. So cx plus d squared. All right, from here, like a lot of other problems, we're going to simplify the numerator by multiplying that out. We'll distribute the a through these set of parentheses and distribute the c through those set of parentheses. And just be careful, we have a minus there. Once we distribute, that minus or subtraction sign will change all the signs of everything thereafter. So just be careful of that. So let's write down our next step in simplifying this. We're just going to distribute, so we're going to get a times c times x. Next, distribute that, we'll get a times d. We have a minus, and just go ahead and now distribute c into parentheses and use the negative to change all the signs. So we'll get minus a times c times x, and then minus b times c. And that's all over cx plus d squared. And it looks like here we have some terms that subtract out. We have acx and negative acx. They're going to subtract, and what we're just left with in the numerator is ad minus bc. And that's basically it. Our numerator is ad minus bc, and then our denominator is cx plus d. Squared. And that is our derivative here, h prime of x. Now make sure you see the calculations here were really simple. It's more of a conceptual question, just making sure you're comfortable being able to differentiate something like 2x and then transitioning to differentiating a symbolic version of that, ax, where a is a constant. It's a really simple calculation, so make sure you get that. And what we're using for both those parts is the derivative of x is 1, and then 2 and a, we're thinking of those each as constant multiples. Once you get that, this question is pretty simple. Hope you enjoyed the problem in finding this derivative, h prime of x. I hope you're learning a lot. If you are, support the channel, like and subscribe.